What if this house could generate its own electricity? Hey everyone, it's Ludo. In this video, this house is about to take a huge leap forward, like it never has before. It's been sitting untouched for decades. I actually started working on it years ago, slowly, very slowly, some might say, at my own pace. And even though I don't spend much time here yet, and there's barely any electrical equipment, I'm already dreaming of a world with no power bills. Alright, maybe that's a bit of an exaggeration, but still, there's work to be done. As some of you might remember, this house sits at about 950 meters elevation, and at that altitude, winters can be long and pretty harsh. Actually, let me grab my beanie. But still, there is sun. So there's definitely something to take advantage of. Here, we can almost heat the house from September all the way to May, and even in summer, when night falls, it gets cool again. I've always had one idea for this house: to get as close as possible to energy independence. And to do that, we're laying the first stone of this project today. In this video, I'm starting a series of 3 themed videos. Each one will focus on a specific topic. The first one is about the basics, for anyone already interested in solar. Then we'll go deeper into my own setup and how it can apply to other installations. The final goal is to show that you can absolutely build a high-quality solar system yourself. But before going further, we need to understand a few key principles. So first, what is photovoltaics? Well, photovoltaics is simply the process of converting sunlight into electrical energy. This is done using solar panels made of cells that turn sunlight into direct current. That direct current is then converted by an inverter or microinverter into alternating current, which can be used in your home at the correct voltage. And then comes the real question: what do you actually do with that electricity? That's where you need to think about your usage, your house, and your future plans. To simplify things a bit, I prepared a small animation that we're going to look at right now. First situation. It's night, or you simply don't have solar panels. You're using 500 watts of electricity, and the grid supplies all 500 watts. Now let's look at the second situation. The sun starts to rise, and the panels begin producing a bit of power. Let's say around 100 watts. Out of the 500 watts needed by the house, 100 watts come directly from the solar panels, because electricity always takes the shortest path. So the panels power the house first, but it's not enough. The grid supplies the remaining 400 watts. Now the third situation. The sun is higher, production increases and reaches 500 watts. Perfect match. The house consumes exactly what is produced, and the grid supplies nothing. This is where it starts getting interesting. Now the sun is at its peak. The panels are producing at full power, around 1500 watts. The house still only uses 500 watts, so there's 1000 watts of excess being sent back to the grid. At first, you might think, great, I can sell that electricity. But in reality, it's not that simple. There are 2 important points to consider. First, you need a specific contract to sell electricity to the grid, and it requires professional installation, which means the installation cost will be at least double the price of the equipment. Second point, selling electricity doesn't pay much. Right now, in 2026, we're talking about around 4 cents per kilowatt hour. That's basically nothing. So honestly, it's not worth it. But there are better solutions. For example, installing a home battery. The house uses 500 watts, and the extra 1000 watts is stored to be used later when solar production drops, like in the evening or at night. Another option is using a solar diverter. It redistributes excess energy to different devices in the house. It's a broad topic. I'll come back to it later since I'll be dealing with it myself. But basically, it sends excess energy to an electrical device. That could be an electric heater. Ideally, this device should be simple, meaning not too much electronics. For example, a basic radiator or a water heater with a heating element. Simple resistive devices work best. It could be oil-filled radiators, domestic hot water tanks, or even a storage tank used for heating. In short, it's thermal storage. As the day comes to an end, solar production drops, and the battery starts supplying electricity to the house. If that's not enough, the grid automatically fills the gap. And without solar production, the stored heat is gradually used. The real benefit of solar is not selling electricity, but simply avoiding buying it. To move forward with this project, I got in touch with a solar specialist. They offered to supply equipment and explain the different solutions that could fit my situation. So my partner for this video is PVDF.fr, and I'm going to show you why I chose them. It's a young French company founded by entrepreneurs with very competitive prices without compromising on quality. That's really what stood out to me. Their target audience is DIY homeowners, self-builders, renovators, and hands-on people like us. They even offer plug-and-play systems. Honestly, it doesn't get much simpler than that, and we'll see it later. So yeah, that kind of approach really speaks to me. What I really appreciated is how easy everything is to understand. When you land on their website and start exploring the different options, everything is clear. You quickly understand how systems work, and most importantly, what you actually need to complete your project. And for me, that was really important, because I have to tell you something. In this field, I'm really starting from scratch. So now, we're going to dive into the world of solar panels and self-consumption. And the first thing I realized is that there are several ways to install solar panels at home. Some solutions are very simple, like plug-and-play systems. Others are more advanced, with a dedicated connection to your electrical panel. And you can go even further, like I mentioned earlier, by adding a battery system. So let's take a look at the different options. To do that, I'm heading over to the PVDF website. Let's start with plug-and-play. For example, here's a 500-watt kit. The solar panels sold by PVDF are all from ICO, a premium brand using a design where the electrical contacts are placed on the back of the panel, maximizing the surface exposed to sunlight. They're also bifacial, meaning they capture sunlight from both the front and the back. So depending on how they're installed, for example on the ground or on a pergola with a light-colored surface, reflected light can hit the underside of the panel and increase production. Next, we have DA inverters, a well-known brand in the solar industry. Then comes the mounting systems, ground mounts, ballasted mounts, roof mounts. Everything is available. What I really liked here is the quality of the equipment being offered. For example, these ground mounts are made entirely of aluminium. They're sturdy and adjustable, while some competitors offer cheaper options made of painted steel with much thinner sections. You can also add accessories, like a power meter installed on your main supply, to monitor exactly how much electricity is flowing in and out, as well as batteries and other components. This kit with mounting hardware costs €474, and for just €175 more, you can actually double the production. Here's why. If you switch to the 1000-watt plug-and-play kit with 2 panels, the trick is simply that the inverter has 2 panel inputs. So this kit uses the exact same inverter, but adds a second panel connected to the available input. And if it's a ground installation, you can easily move it throughout the seasons to optimize production. The limitation is that you can't exceed 3000 watts. Now, there's one important detail to keep in mind for safety. If your solar panels are connected to the same circuit as other appliances, You need to properly size the circuit breaker according to the solar panel power, so you don't exceed the cable capacity. As you can see here, if the breaker rating is too high, part of the cable could exceed its thermal capacity. That's because the solar panels are adding power into the circuit inside the section protected by the breaker. By lowering the breaker rating according to the panel output, you make sure the cable never carries more than it can safely handle. Here's an example of proper sizing to protect the circuit from overload. I also made a simple table with different cable sizes and plug-and-play setups to help avoid any issues. Another solution is to create a dedicated circuit, which completely eliminates this risk. And of course, it's strongly recommended to plug the panels into a high-quality 220-volt outlet capable of handling continuous solar output. Then there are systems with a dedicated electrical box. In this case, you're no longer limited to 3000 watts because, unlike plug-and-play systems, the wiring is sized according to the power and cable lengths involved. This allows you to go beyond the limits of standard outlets and even install multiple systems if needed. The inverters are connected by cable to an electrical box that contains the necessary protections for the solar installation. This box is then connected to your main electrical panel through a dedicated breaker. It might seem a bit complex at first, but with PVDF, it's actually quite simple. Once you've chosen the panel location and with the microinverters installed just underneath the panels, you simply need to plan the cable runs between the panels and the electrical box and determine their lengths. The same goes for the grounding cable that connects the mounting structure. The box is usually installed near the main electrical panel. Then you just need to indicate the distance between the box and the panel, and that's it. The box, wiring, and breaker for the main panel are all included in the kit. It's very intuitive. If your kit includes 2 microinverters, you simply need to provide the cable length between the panels and the AC combiner box. And if the microinverters are interconnected, for example in a 3000 watt system, you only need to enter the length once since there's just a single cable run. So really, there's no need to overthink it. You also have battery systems, related accessories, and even the option to let PVDF handle the paperwork. Speaking of paperwork, let's move on to regulations, at least the ones that apply in France. I'll try to keep it as simple as possible while still covering the essentials. First, let's talk about planning rules. If your installation is higher than 1.8 meters, you need to file a prior declaration. If it stays below 1.8 meters, no paperwork is required, as long as the system is under 3000 watts. Then there are the grid regulations with Enedis. If your system is under 3000 watts, you can use a CAC agreement, which allows self-consumption with free surplus injection into the grid. Above 3 kilowatts, you typically switch to a CACSI agreement, which means self-consumption without injecting into the grid. And if you want to sell your electricity, the installation must be carried out by a certified professional. But, as I mentioned earlier, for someone able to install the system themselves, the benefit is quite limited. Let's take a 3 kilowatt installation done by a certified professional with around 2,500 euros in labor costs. If you sell all the electricity produced at around 4 cents per kilowatt hour, even in a very sunny location like Mayotte, it would take more than 10 years just to recover the installation cost, without even self-consuming any energy. And that doesn't even include the price of the panels themselves. When applying for a CAC or CACSI agreement, Enedis may require a Consuel certificate, but it's important to understand that this certificate does not concern the solar panels themselves. It only applies to modifications made to your home's electrical system. For plug-and-play kits, it's usually not required, as the manufacturer certification is enough. And for those wondering, filing the prior declaration is actually not that complicated, especially if you're comfortable using a computer. To go further, I'll also make a dedicated video where I explain step by step how I prepared my application using free software. You'll be able to reuse it for your own project. I'll also provide downloadable resources and a video explaining how to set up a CAC or CACSI contract. This content will be available to channel members.